How's it going, everybody? I'm going to try to make this short and sweet and simple as possible. We're going to be solving logs and exponentials in this video. In this case, obviously, there's not really any tricks or anything like that. The tricks that I will be doing are that you can use to solve logs and exponentials. I will talk about when I get there. But with this one, there's not really much that we can pull, but I noticed that these are exponentials. If I could write these two numbers as the same base, then this will make it super easy. Well, I know 8 is 2 to the third, and I'm going to leave that x plus 4 out there. And 32 is 2 to the fifth, because 2 times 2 times 2 times 2 times 2 is 32. And I'm going to leave the 3x out there. Well, now I have these same bases. So if my bases are equal, then the exponents must also be equal to each other. So I can say 3x plus 12, because I'm multiplying those, is equal to 15x. And then it's just an algebraic equation. Well, it was an algebraic equation before, but now it's a really simple algebraic equation, right? Algebra 1 equation. Hey. So I can subtract the 3x to the other side. 12 equals 12x, so x equals 1. All there is to it. Happy day. Okay, with this one, same sort of deal. I notice that I have a base of 12 over here. 144 I know is 12 squared, so I can rewrite that one. I'll leave this side the same. 3x plus 11 equals 12 squared. 2x plus 7, so 3x plus 11 equals distribution, so 4x plus 14. Well, if I move over the 3x and I move over the 14, I have x equals negative 3. Cool. Make sure you guys are pausing these and trying them out. I'm going to go fast, like I said. Yay! Okay, same sort of deal as the last two. I know that 5 times 5 is 25. 6 times 6 is 36, so really this is 5, 6 squared. On this side, that is 5 6 squared. So I can rewrite this. So this side's the same. So I'll have a base of 5 sixths. 5 over 6 squared times 9 minus x. Oh, I don't need that parentheses. I don't need that parentheses. I'm sorry, I shouldn't have written it. Okay, so then you can take this and solve from there. So you have 4x equals 18 minus 2x. Move over the 2x. So you have 6x equals 18. X equals 3. Happy day. Alright, now we get to one where we actually have to think about this. Well, I know back from 3.2, I know how to rewrite logs as exponentials. It'll look something like this, right? Hopefully you remember those things are interchangeable. But what I notice about this log over here is it doesn't have multiplication in front. It doesn't have plus or minus any number on the outside of it. This is the only thing, and it is inside of the parentheses, so it is inside of your log. But if I divide by negative 8 on both sides, then this will be log of b equals 8. I know that my base is 10 because that is understood, so this is 10 to the 8th power equals b, which is, I think, 100 million, yeah, something like that, but you can leave it like that. I'll be happy with that. Yay, we did a problem. I keep not pausing it. Okay, with this one, again, the same sort of deal. I have a single logarithm on the left side. My base is e, so I could say e to the x equals negative 3, but there's really no power that I could raise this to make it become a negative number. So also, if you look back to your original function, we know because Mr. Pike told us that you can never take the log or natural log of a negative number. So with this one, even just looking at that, can't take the log of a negative number, so I've already written no. You can guess that the next word is solution. Huzzah! Alright, with this one, there's a few different ways of doing this. I will show you probably the easiest way, the fastest way, because if I have this exponent up here, the power rule tells me I can take this and move it in front of the log, so I have 4 log base 2 of m equals 32. And then just like in the second to last one that we did, the one with the negative 8 log b, blah, 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 I can divide by 4, and then this is log base 2 m equals 8. I can rewrite this as 2 to the 8th equals m, and Mr. Pike is happy. I think that's also 256. I'm sorry if I'm wrong. I'm just guessing in my head. I think it is, but maybe not. I don't know. All right, with this one, this is our first one that we see 2 logs. Again, a few different ways to do this, but what I see first is that my bases are the same. So if my bases are the same, then the log of something has to equal the log of something else. Well, then those insides must be equal. So I can say that by deduction, I think, deducing, yeah, Sherlock Holmes, Watson, yeah, I think so, that x squared plus 5 equals 41, and then I can just solve this real simple. X squared equals 36, take the square root, so x is plus or minus 6. Make sure you check both of your answers, because this negative 6 is worrisome, but if we substitute it back in, we will have negative 6 squared, which will make it a positive 36, plus 5 is positive 41, so I can take the log of that number. So we are cool. If it ever comes out that you cannot take the log of a negative number, if you plug it back into your solution, which is one coming up, maybe the next one, I don't remember. But if it doesn't work, then you have one that is not a solution. So you would only have one or two solutions in this case. So we are happy there. Yeah, it'll make sense soon. I promise. Just stick with me. I love you guys. I wrote it a little big, but that's okay. You can still read it. All right, with this one, I notice I have 1, 2, 3 logarithms. But if I have subtraction of logarithms, then I can take this part, divide it by this part, throw it in one logarithm by the quotient property. So I have log base 5 of x equals log base 5 of x plus 6 over 4, where that is all inside of one natural log, or sorry, one log. And then same base, so I know the insides must be equal, just like in the last one that we did. So we have x equals x plus 6 over 4, multiply the 4 over, 4x equals x plus 6, 3x equals 6, x equals 2. Cool. All right, with this one, there's no way to get these bases to be the same number, but what we can do is I have a base of 6, and I have 28, so I could rewrite this as log base 6 of 28 equals x, and then I can use my change of base formula to say log of 28 over log 6 is equal to x, and then plug it in my calculator, and I will get a happy-pappy number. All right, I'm going to show you guys another method that is kind of a shortcut method to the change of base formulas and rewriting it as an exponential function, rewriting as a logarithmic function. There we go. If I have my variable in my exponent, what I think to do, because this is how I was taught when I was your age, and this is what I did when I was in college, is I can move this in front if I had a natural log or a log there. So if I get rid of this 3 such that that 3 is not, because this 3 is not to the 4x power, only the e's to the 4x power, then this would give me e to the 4x equals 15. And now what I can do is, since I know the bases of this are the same, of natural log are the same, then the insides must be equal, which is where I just came from. But here, check it out, that base is e, so this side is equal to just 4x, so I have 4x equals natural log of 15. And then it's just a matter of divide by 4, and x equals ln of 15 over 4, which will give me the decimal 0.677. And there we go. Okay, I'm going to do this one the same way that I did the last one. So I'm going to get rid of this 1 first by adding 1 to the other side. So I have 8 to the x equals 4.4. Then I can take the natural log or log of both sides. It really doesn't matter what you do. I just take the natural log because it is shorter to right. So now I can move this x out in front, and I have x ln 8. And I'm talking really fast, equals ln 4.4. Then just divide by ln 8 on both sides. Punch this in your calculator, and you will get the decimal 0.713. Happy day. Okay, ones like these are kind of fun. You're going to have to bear with me. You may have to watch this one a few times in order for it to make sense. Because really, it's just a matter of factoring. If we had x squared plus 3x minus 130, right? Because I know x times x will give me x squared, just like e to the x times e to the x will give me e to the 2x. So that's the first part, e to the x and e to the x. They have to add to be the middle number, multiply to be the last. So I know I can have plus 13 minus 10, still equal to 0. And pretty much I've just factored these out. I know these will add up to be 13 e to the x minus 10 e to the x will be plus 3 e to the x. E to the x times e to the x will be e to the 2x because you add the exponents when you're multiplying. And from this point, all you have to do is just set these to 0 and solve. So if I take e to the x plus 13 equals 0 and e to the x minus 10 equals 0, I have e to the x equals negative 13. Take the natural log of both sides. This one will not work because x cannot be ln negative 13. So that one is not possible. However, on this one, e to the x equals 10. And again, I'll take natural log on both sides, ln. So I have x equals ln 10, which in your calculator, 2 point, what is that? That's like a 3-2. 2.30. Happy day. Rewatch that one, please, please, please. Help yourselves. Alright, with this one, I notice I have 1, 2, 3 natural logs, but I have addition between, so I can combine them using my product rule, which is multiplication. So ln of x times x plus 2, where that is all inside the natural log, equals ln 63. And then I can distribute this, say the insides must be equal, so I have x squared plus 2x equals 63. And then it's just a quadratic function, so I can move over that 63, x squared plus 2x minus 63 equals 0. 7 and 9, so plus 9 minus 7 equals 0, x equals negative 9, x equals 7. Okay, now like I said, make sure you go back, look at your original equation. If I substitute in negative 9 for all of my x values, this would be natural log of negative 9, which is not possible. This would be natural log of negative 7, which is not possible. So negative 9 is not an actual solution. If I substitute 7, ln of 7 exists, and natural log of 7 plus 2, which is natural log of 9, exists, so this is my only solution. Make sure that both of your solutions work or both of your solutions do not work. Double check your work. Please, please, please. Get a good grade. I love you guys. Alright, I know we're setting a new land speed record with how many problems we can do in probably, I don't know, 13 or so minutes. So with this one, this is our last problem. This too kind of throws a wrench in things because it does not have a log involved. Oh, sorry, this should be log. Log, change that to log. My bad, I'm sorry, I wrote the wrong thing. I love you guys, you know what happens. Okay, but if I move this log of x minus 2 over to the other side, so I'm going to do that same thing over there, then I will have log of x minus 12 minus log of x minus 2 equals 2. That's a 2. Pause the video if you need to rehear me say what I'm saying. Or writing, and then I know I have subtraction, so there's the quotient, so log of x minus 12 over x minus 2 equals 2. And then I can rewrite this, since this is a base of 10, as 10 to the second power equals x minus 12 over x minus 2. 10 to the second power is 100, so I have 100 times, since I'll multiply by x minus 2 on both sides, times x minus 2 equals x minus 12. So I have 100x minus 200 when I distribute equals x minus 12. I will move over this x, so I will get 99x, and I will move over this 200 by adding it, so I will get 188. So I have 99x equals 188. And when I do the division by 99, x is equal to... I wrote a 2. It's not really 2. Hang on. Even though it does round to 2, make sure you give me the proper decimal. Okay, and that's all I have for you guys. We made it in under 13 minutes. Hopefully this video was helpful for you. Make sure you try all of your homework, and you should do great on the quizzes. Oh, that was a chopped off monkey's head. All right, whatever questions you got, come ask me in class. Love you guys. See y'all later. Bye-bye.